How you guys doing, everyone? I'm Rob Patel, and welcome to my first tutorial on 360. Today we're going to be talking about binary numbers, decimal numbers, and hexadecimal numbers. So before we begin, let's do a little breakdown on what each one is. So decimal numbers are what we see in everyday life. So what we learned in kindergarten, like 1, 2, 3, 4, 5, 6, 7, 50, 60, 80, those are considered decimal numbers. And it's done through base 10. So keep that in mind when you do other formulas, when you do conversions. Binary numbers, they're done through ones and zeros. Binary numbers usually mean if it is a 1, please include it. If it's a 0, please do not include it. And a great example of it is the first example, which you could see on 1, A11. Now, many people would be like, oh, that's a decimal number, isn't it? Because we consider that 11. In computer programming, especially when you're reading information through a computer, they will read it in binary numbers. So 1, 1 in their terms would be 1, which is 1 plus 2. So let me give you an example why that is the case. So let me clear this out really quick. And we're going to do number 1a, which is 1, 1. So in computing, they would look at this and they would say it's 3. Now, how did the computer get that answer to become 3? I'm going to show you how. So the first value right here is a 1, and every time you should always start from the right and go to the left. So that 1, the first value, is 2 to the 0. Every time the first value is 2 to the 0. And then the second value right here is 2 to the 1. So you're like, oh, how come it went from 2 to 0 to 2 to the 1? So every time you move up a value, you will go up by 1. This is also similar to how we look at base 10 values. So imagine 10, right, as a decimal representation. Imagine 100. You're thinking, those are two different numbers. 100 is bigger than 10. This is done through base 10 decimals. Similarly, the other one is done through base 2. So I think a better way is for me to give examples. So let me give an example for another binary one, which is 1b, which is 1, 1, 0, 1. So the first one, since you're doing it by base 2, will be 2 to the 0. Next one is 2 to the 1. Next one is 2 to the second. Next one is 2 to the third. Okay, so one thing that you have to keep in mind, it's always great to write out every one of these values, but make sure if there is a 0, you cross it out. So let's go one by one. So the first one is a 1, so 2 to the 0 is okay. Second one, which is a 0, so you have to cross out 2 to the 1. Third one is 2 to the second, so that one's okay. And the fourth one is 2 to the third, and it shows a 1, so that one's okay. So what would you do? You would add up these values. So that would be 8 plus 4 plus 1, which would equal 13. So 1b would be 13 in decimal representation. So other than binary and decimal, there's one more representation, and that is hexadecimal. Now hexadecimal, as you can tell, is done a little differently. It's done through base 16. This is just a handy note I have in mind. It's done through base 16. And hexadecimal makes it easy for computers to communicate with binary. So I'll give you an example. So hexadecimal, this is one example which I'm going to give you so far. So on the left side is decimal representation. The right is hexadecimal representation. So you go up to about 3, but let's just skip it down because it's going to be the same. And let's go to 9, which is 9. And then when you go to 10, that turns to an A. You're thinking, what in the world just happened? Why is that an A? It's easier for computers to read in hexadecimal representation because then go from 1 through 10. So I'll give you an example. Let me go back to 1B, which is 1101. Now you would look at this example and be like, okay, this is fairly simple. Like, the answer we got was 13, And yes, the answer you got is 13 in decimal representation. But what about in hexadecimal representation? You want to get the same answer as 13. And why is that? You want to get the same answer as 13. So let me just break this down. B 11, 12, 13. So that would be D. And how did I get to that value? I think the best way to really get to this value and understand is by looking at the reference summary. So reference summary is basically a yellow card for assembler programming. So make sure you print yourself out a copy. I do have one myself, and I do look at it from time to time so I can really understand this code. So let me just show you what the reference summary is really quick. So reference summary is like a yellow card to help you really, it's like a cheat sheet. I wouldn't say cheat sheet, it's a reference page for assembler programming. And this makes life a lot more easier because a lot of people, they try to memorize information, and even though you memorize information, you still need some guidelines throughout the time because there's a lot of information in assembler code programming. So you want to make sure you get it. And towards the last page, which is going to be page 39, you'll see a reference summary. Now let's see if we can flip this. There you go. So there's a reference summary. I think I missed it. Nope. Yeah, I think I missed it. I don't think it's page 39 then. I think I know which page it is. There it is. Yeah, I missed it totally. Sorry about that. I try to prepare for this lecture a lot more. And you're trying to understand information and try to process it, and it's very difficult. So towards the end, these are your decimal value, which is everyday use values. So you look down and you see, whoa, hexadecimals? I don't even have to memorize this. I could just look at this reference summary and get the job done. You could. Honestly, you could. And some information on here is easy, but some information isn't. I'm pretty sure reference summary doesn't go up to a huge amount of number. So after 255, you have to do some calculations by yourself. And that's one problem in the assignment, which is C, which you won't see in the reference summary, but you have to make calculation yourself. I'll teach you how to do that. So in the reference summary, you're able to look at decimal versus hexadecimal conversion. So for the one that we did, 11, no, it was 13. Give me one bit. I did so many of these. Yep, 13. You would see D. And that would be the answer if you were converted from decimal to hexadecimal. It would be D. Now remember this D, okay? And look at the binary, which I'm going to type up the binary really quick, once again, which is 1101. 12, 13, yep. Now, usually when you read code, you want to read it by 4 bytes or bits. Man, it's been a while. But you want to read it by 4 in a sense. So this one is D. You start to see that you're like, oh, okay. What about if I were to have like another one? Okay, similar to this. So this is 8 plus 9, that'll be 9. And you will start to break it down. It'll be so much easier for assembler. It'll be so much easier for a program to break down these values than they were to add up their other values, such as like 13, 9. It'll be very difficult for the computer to break down values because they're not designed the same way. Similar to like if a teaching style, like I don't learn the same way as everyone else does. I have to really go off to the side, learn the material, and figure it out how to process a program just by the way I think about material. So this is a brief overview about decimal numbers, binary numbers, and hexadecimal numbers. I could go over the homework problems with you guys if you guys do request it. And if you guys have any comments, please place them below and I'll be able to answer your questions. Thank you guys.